This is an original Commodore 1581 floppy drive, an expensive purchase back in the 80s and still quite costly today. Is there a cheaper path to 1581 ownership? I'm Matt D'Amico, and all is about to be revealed right now in episode 49 of Retro Bits. The Commodore 1581 was released in 1987 at a retail price of $400 or around $900 in today's currency. While they quickly saw price cuts in the first year of sales, they were still an expensive upgrade at the time. The new 3.5-inch double-sided double-density drive used MFM encoding to store 800 kbytes on a single disk, nearly 5 times the formatted capacity of the venerable 1541. The drive was also capable of reading PC-formatted disks when used with special software. Like other Commodore models of the era, the 1581 was a smart drive, basically a computer in its own right, with a 6502 CPU, ROM, RAM, and I/O. New to the model was support for partitions and subdirectories. And like the 1571, fast and burst modes were supported when paired with a Commodore 128 for high-speed transfers. In real-world testing, I've measured speeds as high as 6 kbytes per second. Sales figures are elusive, but Robin of 8-Bit Show and Tell made a video where he used the German tank problem to estimate that around 60,000 of the drives were sold over its 4-year run. I've placed a link to his video below in the description. So, a decent number of units were sold, but nowhere near the volume of Commodore 64s and 128s, which numbered in the tens of millions. Finding one today isn't that difficult on eBay, but average prices are around $300, with some units selling for as much as $500. I obtained this drive for free years ago, but buying one at market price these days would be out of the question. There's good news though, because recently it's become possible to build your own replica 1581 from new parts. So, let's take a look at what's required, attempt to build our own copy, and then see how it stacks up to the genuine article. Right, so what do we need to build a new 1581? For starters, we'll need something to hold all the bits. And, as luck would have it, I already have just the thing. In the Toronto estate sale video, I mentioned how I came by this new old stock 1581 case, but here's a quick recap. As I understand it, Commodore had an excess of unsold units, so they unceremoniously ripped the insides out of these poor 1581s in order to reuse the drive mechanisms in new Amigas. A third party acquired the lot, and for many years you could purchase a kit containing a case, logic board, and power supply. Then add your drive to have a complete 1581 on a shoestring budget. That was then, and it appears that I may have picked up the very last of this new old stock at the Virtual World of Commodore event back in 2020. I only paid $15, but this last unit did not come with anything but the bare shell. Of course, you don't need an original shell to build this project. Models are available to 3D print your own at home, as demonstrated in this forum post. 3D printed cases are also available for purchase on eBay, although they are costly at $70 to $80. Other forum users have gotten creative with their builds, as evidenced by this awesome clear printed case, this smoke plexiglass model, and this wooden enclosure. Next is the most important part of the build, the logic board. If you needed more evidence that we are truly in a golden age of retro computing, this is it. You can now purchase a reproduction 1581 PCB to go alongside any of the multitude of replica C64 or 128 motherboards of your choosing. The part was designed by forum64.de user Toms01 and is available for purchase on AmiBay at a cost of €10 or around $12 US plus shipping. I've opted for the full kit that includes brand new parts for the proprietary MOS chips, discrete components, and everything else required in order to complete the board. You could source used components from dead hardware you may already have on hand, as the CPU was used in other drives like the 1541-2, and the CIA is a standard Amiga part. As a bonus, the board has a few enhancements over the original design, giving you the option of using an original 6502A CPU or the newer W65CO2 that you can order from Mouser for around $10. This small PCB is an add-on that was thrown in for free with the kit. Its purpose is to allow you to use an off-the-shelf PC drive in your build instead of a Commodore-specific unit. The 1581 and Amiga drives differed from their PC counterparts in a few ways. For starters, drive select 0 is required instead of the PC's DS1. The disk change signal is carried on pin 2 instead of 34. And on 34, the Commodore expects the ready-to-access signal that the PC doesn't use at all. The small adapter takes care of remapping all the signals and derives the ready signal from existing lines as well, making the use of a standard PC drive a plug-and-play affair. I'll just need to place an order at DigiKey for the required components, which came out to around $4. Let's talk about drive options. I've already got a bunch of old PC drives lying around, as well as the adapter board. Another option would be to use an Amiga drive, which is directly compatible, and I just happen to have that 1010 from the estate sale lot I wasn't using. Last, a Gotek could be used either directly in the 1581 or in the 1010 to replace the part that was borrowed. This TIAC unit was the one I picked up in the Hamfest video for $2. It's a good option as it has documented support for 800K double density disks, and the model is known by the Amiga community to be easily modified. That said, there's a problem. This particular revision has a part of the cast metal housing in the way where the 1581 eject button would need to sit, meaning I'd have to take a Dremel to it. While reading through the Replica PCB Designer's forum posts, I found that he used a Samsung SFD 321B in his own build. As it turns out, I had the exact same model of PC drive in my parts bin. I mean, come on, what are the chances? Knowing that this particular drive should work well does add some peace of mind. On the forum, he even provided 3D models for the drive sled and modified eject button to fit the 1581's housing. And through the magic of YouTube, here's what that part looks like for this drive. How awesome is that? If you don't have this model, fear not, because there are 3D models for other drives available as well. Right, what else? Well, you'll need a power supply. These are readily available on eBay, and I recently picked up one in the Auctions and Thrifts video for $20 with free shipping. There was also one in the estate sale lot that didn't match up to any drive, so we'll call that a freebie. You'll also need a 34-pin drive cable. I picked up this average size 6-inch part for $4. You don't want it to be too long or it might not fit. I don't know about you guys, but I am constantly amazed that you can find something so niche like this out on the internet and then have it brought into the real world right in the comfort of your own home. We take it for granted these days, but the availability of inexpensive 3D printers and the tools to create with them is incredible when you stop and think about it. With all the necessary parts accounted for, it's time to get this build started. This will definitely be the most complicated project I've attempted so far. So, here goes nothing. Here's another reason to own a 3D printer: making tools you didn't even know you needed. This lead bender is awesome in its simplicity, yet ensures a perfect fit every time. This reproduction board has been optimized to make use of a modern oscillator and resistor arrays. These 8-pin parts have 7 separate resistors inside and share a common ground. Therefore, orientation matters, so look for the little dot that indicates pin 1. Also, take care to check the resistor value because one of the 3 parts isn't like the others and you don't want to solder it in the wrong place. Ask me how I know. Like the resistor packs, this 16 MHz oscillator also has a dot indicating where pin 1 is. So yeah, I didn't look before I leapt and soldered the wrong resistor array in before I realized that one had a different value. Undoing my mistake was difficult even with a proper desoldering gun because the through holes are quite tight and the solder wicked up to the other side. I ended up damaging the part and had to order a replacement for 60 cents, plus nearly $7 in shipping. Fantastic. At least I made the mistake so you don't have to. Nearly done now, just a few last details. When working with LEDs, the longer leg is the positive side or anode, and the short leg is the negative side or cathode. The PCB silkscreen clearly indicates which is which for easy assembly. And there we go, looking pretty good if I do say so myself. I'm really happy with how this turned out, minus the one little oopsie with the resistor pack. There are 3 solder pads that must be configured. JP1 and JP3 are used to select between an original 6502A and the newer W65C02 CPU. JP2 is used to choose between an original SRAM chip or a more modern equivalent. I thought I'd be clever and try to use a kitchen sponge and some IPA to clean the flex residue from the back of the board. Unfortunately, the sponge wasn't up to the task, and even though I was being careful, it still started to catch on the sharp edges and rip apart. So back to my trusty nylon brush I went, but in the end, I just ended up with a sticky mess. I may have to invest in some proper flux remover. Before I install any of the ICs, let me quickly test the board, just to ensure that nothing is shorted and the proper voltages are where they need to be. First, I'll test with the power switch in the off position to ensure that that's working correctly. This header provides 5 and 12 volts DC to the floppy drive. Alright, that's looking good. This checks out as well. And finally, let's test the 6502 socket. Wouldn't want to damage my shiny new CPU. Perfect. With the safety checks complete, it's time to install the chips. This updated board allows for your choice of CPU and SRAM. In this case, I'll be using an original 6502A. The board also allows for larger capacity EEPROMs, so you can have switchable ROMs such as Jiffy DOS if you so desire. One hard requirement is the 8520 Complex Interface Adapter, or CIA chip. These are derivative of the 6526 used in the C64 and 128, but with a revised time of day clock. These chips can be sourced from an Amiga, but I'm using all new, old stock parts in this build. Soldering and other precision tasks like this are made more difficult when filming, as you have to maintain an amount of physical distance from your workpiece so as not to block the camera. As a result, I did find a few bent legs upon close inspection and had to straighten them up. Hey, it's starting to look like a real boy now. I'm both excited and nervous at the same time. I sure hope I didn't mess anything up. I've decided that I'm going to try option 1, using the PC drive. Here's the adapter board with the required components I ordered. And, with a little more YouTube magic, here's the finished product. The adapter is designed to fit perfectly on the 1581 board, relocating the 34-pin data and 4-pin power connectors. Before I assemble the 1581, some bench testing is in order. Let me connect up the front panel LEDs and attach the Samsung drive to the PC adapter. It's very important that you make sure to align pin 1 on the PCB with pin 1 on the drive. The red stripe on the cable is for this purpose. Same goes for the power connector. Pin 1 carries 5 volts and pin 4 carries 12, so don't get them backwards. Okay, it's finally time to connect everything up and see if the weeks of research and carefully assembling this thing paid off. With fingers crossed, here goes nothing. Well, that's promising. The status lights indicate a successful boot and the drive activated. Only one thing left now. I am beyond nervous at this point. Oh wow, I can barely believe my eyes. No editing tricks, you're seeing this as I'm seeing it. Honestly, I'm shocked that it just worked on the very first try. I'm at a bit of a loss for words right now. Since everything works, it's time for final assembly into the case. First, I'll need to separate the LED panel from the main PCB. Now to secure the drive in the 3D printed sled. The 1581 shell didn't come with all of its original screws, so I'll need to dig through my reserves to find something suitable. It's a good thing I've kept every extra PC screw since my very first 386 machine. You never know when you might need one. Maybe someday I'll have a need for this 7-segment turbo display again. One can always hope. I thought I'd be all clever and crimped up this power connector to the required length. Unfortunately, the Molex terminals I had on hand were the incorrect gauge and didn't really fit the power connector pins, so I'll have to order a larger size and do it again later. Oh yeah, that's not looking half bad. I love it when a plan comes together. One small issue. The eject button should protrude a little from the case even when no disc is inserted. No big deal though, we have the technology. We can make it better than it was. I suspect there are different revisions of the PC drive with some slight eject button variations. I'm going to take the 3D model I found on the internet and lengthen it by 4mm. That should do the job. And there we go, easy peasy. Well, I don't think that could have turned out any better. I still need to put the drive through its paces though, and to start, let's see if it can read this disk that I've created with my real 1581. Awesome. No issues with interoperability. Next, I'll format a disk in the new drive and make sure the original unit can read that as well. Perfect. I'm going to go ahead and call this project an absolute and unqualified success. Alright, so let's talk about what it would cost to build a replica 1581 of your own. I'll include a low and high-end price for each component and also what I spent on my build. Note that none of the prices shown include shipping costs or applicable taxes. First, the case. The shell can be 3D printed or built from a number of other materials. Your creativity is the limit here. If you have your own printer already, it'll only cost you filament, power, and time. On the other hand, if you buy a ready-to-use case on eBay, it'll run you about $80. I was lucky to be able to source a new old stock case for $15 a few years ago, but the supply has since dried up. Next, the PCB is pretty much a fixed cost at €10. There are plans to open source the board, but right now it's only available for purchase on Amibay. Other members of the community are working on producing their own cost and size reduced versions as well, so look out for those soon. The cost of components is going to be the biggest variable. If you have all the necessary 74LS logic chips on hand and a supply of old, broken Commodore systems and drives to scavenge from, you may already have most of what you need. Otherwise, you'll need to source a 6502, EEPROM, SRAM, 1772 floppy controller, and 8250 CIA chip from the market. I acquired all of the necessary components from the PCB's designer in a convenient kit and happily paid for the new old stock parts. As we discussed, you have several options when it comes to the drive mechanism itself. If you have a PC drive on hand as I did, you'll just need to adapt it to fit the case of your choice. You could also pick up a used Amiga drive on eBay, or even use a Gotek. If you already have an extra power supply from a 1541-2 or 1581, you're good to go. If not, there are lots of choices on eBay and from aftermarket vendors. I picked up a spare for 20 shipped not that long ago, and another extra I'm calling free in the Toronto auction lot. The PC adapter is open sourced on GitHub, and a copy was included free with my reproduction logic board. I just needed to buy the parts to populate the board from DigiKey, as the kit didn't include those. I'm calling it $8 because I bought 2 of everything, even if I only used half the parts in this build. So here are the totals, and as you can see, they vary pretty wildly from one extreme to the other. If you can 3D print your own parts and have a drive, chips, and power supply on hand, you might be able to build a reproduction 1581 for only the cost of the board. The more likely scenario is that you'll be buying some or all of the parts. If that's the case, be careful because it's entirely possible to shell out as much as a real 1581 costs right now on the used market. I was able to complete this build for a little less than half the going cost of an original drive, but I was particularly lucky to be able to find the shell for only $15 back in early 2020. So, takeaways from completing this build? Well, first off, this project is a little more advanced than anything I've worked on to date. A fair bit of planning and research is required to complete the drive, including reading through over 40 pages of machine-translated forum posts in German. If you've made it this far into the video, you should have a pretty good idea by now if it's something you want to take on yourself or not. Just be careful to control for costs and check each component's value and orientation before soldering. I just have to say it, I've always loved the 1581. It made a great addition to my CNET 128 BBS back in the day, and the design still looks amazing today. I personally think it's the best looking Commodore drive ever made, and that goes for the Amiga era as well. And it performs as well as it looks. Jiffy DOS and 128 modes are blisteringly fast. That said, with cheaper modern devices like the ST2IAC, there's not much practical use for a 1581 today. Still, no collection is complete without one, or two. And I'm really glad to have been able to restore this empty shell back to its former glory, despite it having to wait over 30 years. So, what's next for this replica? For starters, I'd like to prime, sand, and paint the eject button for a better finish and color match. I also need to adjust the lead lengths on the LEDs so they sit deeper in the front bezel. I'm going to disable the Samsung's built-in light as it's no longer necessary. And once I get the correct fittings, I'll crimp up a new power cable for the drive. And that's really it. Because otherwise, this replica 1581 is perfect, and I couldn't be happier with it. It was a fun project and I learned a bunch in the process, which, after all, is kind of the whole point. So, a big thanks to Toms01 for designing and making the replica boards available. Thanks as always to my patrons for their support. I hope you enjoyed this bit, thank you so much for watching, and we'll see you next time on RetroBits.